Hello everyone, this is Ramya, Assistant Professor of Physics, Theivanai Ammal College for Women at Villupuram. Today we will discuss about physics of nanoscience and technology. Overview. Here we discuss about fundamentals of nanotechnology, history and classification of nanomaterial application and future scope. Fundamentals of nano. Nanoscience and nanotechnology deal with the study and application of material at the nanoscale, typically from 1 to 100 nanometer. At this scale, material exhibit unique physical, chemical and biological property due to their high surface area to volume ratio. And here we see quantum effect which are not seen in bulk material. And mainly nanoscience focus on understand these property, while nanotechnology apply this knowledge to develop new material, devices and system. Like scanning, tunneling microscope and atomic microscope is the basic tool to analyze the nanomaterial. Here various tools like scanning, tunneling microscope and atomic force microscope are used to observe and manipulate nanomaterial. And nanomaterial are categorized based on 0 dimension, 1 dimension, 2 dimension, 3 dimension. 0 dimension is nothing but nanoparticle, and 1 dimension, for example, nanowires. For 2 dimension, graphene thin nanomaterials are we use 2 dimension, and 3 dimension nanocomposite. They can be synthesized using basic fabrication method, that is top down approach and bottom up approach. In top down approach we can classify ball milling lithography. In top down approach, in bottom up approach we can classify sol gel chemical vapor deposition. And mainly fundamentals of nanotechnology is focus on nanotechnology find application in medicine like drug delivery, supercapacitor, electronic. In electronic we use nanochip. Energy, in energy we use energy storage capacity, battery, supercapacitor. And environment, purification. And material science, stronger and lighter material. However, there are growing concern about toxicity and environmental impact of nanomaterial, highlighting the need for proper regulation and safety. These are the fundamentals of nanotechnology. And history of nanotechnology. In ancient time, they unknowingly used ligurous cup. In ligurous cup is Roman glass. If we reflected the light, it show green color, and if we transmitted the light, it show red color. And in 1959, Richard Feynman give talk about there is a plenty of room at the bottom. It's idea about manipulating atom individually. This is the basic concept start from nanotechnology. In 1974, Norio Taniguchi first used the term nanotechnology. It defined working with material at nanometer scale. And in 1980s, SGM and AFM inverted. Scanning tunneling microscope inverted in 1981 and atomic force microscopy inverted in 1986. This is the tool to see and manipulate atom. In 1991, carbon nanotube discovered by Sumio Ijima. It's strong, light and conductive. It is widely used in nanotechnology. 2000 onwards, nanotechnology growth and application used in medicine, electronic, energy and environment. Classification of nanometer. First, I already said that there are 3 types of classification: 0 dimension, 1 dimension, 2 dimension, 3 dimension. In 0 dimension, all dimension are in nanoscale 1 to 100 nanometer. It's no length, width or height beyond nanoscale. Example, quantum dot, gold nanoparticle used in bioimaging and drug delivery. And 1 dimensional nanoparticle. In 1 dimensional nanoparticle, only 1 dimensional is large. The rest are at nanoscale 1 to 100 nanometer. Look like wires or tube. Example, carbon nanotube, nanowires used in it is used in electronic, sensor and energy storage. 2-dimension nanomaterial. Its only thickness height is in nanoscale, 1 to 100 nanometer. It look like sheet-like or layered structure. Example, graphene, thin film, nano coating. It is used in solar cell, battery, touch screen. 3-dimension nanomaterial. Structure made up of nanoparticle or nanolayer. Appear as bulk material but have nanoscale feature. Example, nanocomposite. It is used in catalysis, medical implant, coating. And application. It is used in medicine. In medicine, particularly drug delivery, bioimaging, and tissue engineering. In electronic, particularly it is used in nanochip, quantum dot, and flexible display. In energy, supercapacitor, battery, it give high efficiency solar cell, battery, and future cell. Environment. In environment, nanotechnology is particularly used in water and air purification, pollution reduction. Textile. In textile, we use nanotechnology in waterproof, UV protective, and antibacterial fabric. And then agriculture. In agriculture, we use the nanotechnology in nanofertilizer, nanopesticide, and smart sensor. Then food industry. In food industry, we use for small packaging and shelf life enhancement. And aerospace and automotive. In aerospace and automotive, we use nanotechnology in lightweight material and nano coating. Then cosmetic, transparent sunscreen, and deep penetrating skincare. Construction. In construction, we use for nanotechnology stronger self-cleaning and heat-resistant material. And future scope, we will use for nanorobot for dark-headed drug delivery and non-invasive surgery. For quantum nanochip for ultra-fast energy efficient computing. In self-healing material for aerospace, automotive, and construction. High efficiency nanostructure solar cell and battery. AI powered nanosensor for real-time health, environment, and agriculture monitoring. Thank you.